Measurement of length. Measurement of large distances. Parallax method. This method is used to measure the distance of planets and stars from the Earth. Parallax. Let us hold a pen in front of our eyes. Now, if we look at the pen by closing the right eye and then the left eye, we observe that the position of the pen changes with respect to a background. This relative shift in the position of an object with respect to the background is called parallax. The distant points of observation is called basis. Parallax angle. The angle theta subtended by the base of the object is called parallactic or parallax angle. In case of astronomical objects, moon, star, etc., the angle theta will be extremely small and cannot be measured. To remove this difficulty, we take points E1 and E2 at a reasonable distance apart. E1 and E2 are the two positions on Earth such that E1 equals B. Then distance or distances from Earth can be calculated by the formula theta equals B upon S or S equals B upon theta, equation 1. Phi 1 and Phi 2 are the angles subtended by the distant stars at position E1 and E2 respectively. Then theta equals Phi 1 plus Phi 2. From equation 1, we get S equals B upon Phi 1 plus Phi 2. The values of angles Phi 1 and Phi 2 are measured with the help of a telescope. Copernicus method. This method is used to determine the distances of inferior planets from Earth or from Sun. In the figure, E represents the Earth revolving around the Sun S in a circular orbit. P is an inferior planet revolving around the Sun in another circular orbit. Let ES equals RES, which equals 1 AU fixed, and PS, which equals RPS fixed. As the Earth and the planet revolve around the Sun, the distance between them, PE equals RPE, keep on changing, and so does PES, which equals E, which is called planet's elongation. It is maximum when the angle subtended by the Earth and the Sun at the planet is sin E equals PS upon ES, which equals RPS upon 1 AU. RPS equals sin E AU. Also, cos E equals PE upon ES, which equals RPE upon 1 AU. RPE equals cos E AU. As E is known, RPE can be calculated. Kepler's third law method. The distance of a planet can also be calculated by Kepler's third law of planetary motion. According to this law, the square of time period of revolution of a planet around the Sun is directly proportional to the cube of average distance of the planet from the Sun, that is, T square R cube. If R1 and are the average distances of two planets from the Sun, and T1 and T2 are time of revolution, then T1 square upon T2 square equals R1 cube upon R2 cube. R2 equals R1 into T2 upon T1 raised to the power 2 upon 3. So, knowing R1, T1 and T2, we can find R2. Measuring of very small distances, size of a molecule. Avogadro's method. According to Avogadro's hypothesis, volume of all atoms in any mass of the substance is 2/3 of the volume occupied by the total mass of that substance. Let m be the molecular weight of any substance, then it will contain n number of atoms, where n is equal to 6.023 into 10 raised to the power 23, Avogadro's number. Therefore, number of atoms in 1 gram substance equals n upon m. If r is the atomic radius, volume of 1 gram substance equals n upon m into 4 upon 3 pi r cube. If rho be the density of substance, then the volume of 1 gram substance, V equals 1 upon rho, volume is equal to mass upon density. According to Avogadro's hypothesis, n upon m, 4 upon 3 pi r cube is equal to 2 upon 3 V, which equals 2 upon 3 into 1 upon rho, or 2 upon 3 rho. Therefore, R equals n 2 pi n rho raised to the power 1 upon 3. Thus, radius r of the atom can be calculated. Size of molecule of the oleic acid. Firstly, the concentrated solution of oleic acid is prepared by dissolving 1 cc of oleic acid in 500 cc of alcohol. Then, n drops of this solution are put on the surface of water so that a film of oleic acid is prepared. This film is stretched so that its thickness is just equal to the molecular size. With passage, alcohol is evaporated, and a thin layer of oleic acid is formed on the surface of water. The area of this layer is measured with tracing paper and a graph paper. Volume of n drops equals NV volume of oleic acid in n drops of solution, which equals NV 1 upon 500 cc. Thickness of film equals volume of film upon area of film. T equals NV upon 500 A centimeters. Since thickness of the film is equal to the molecular size, therefore, molecular size can be calculated. Measurement of mass. We know that mass is of two types: inertial mass and gravitational mass. Measurement of inertial mass. Inertial mass of the body is measured by using an inertial balance. It consists of a long metallic strip. One end of the strip is clamped to a table, and the other end vibrates horizontally, as shown in the figure. Let T1 be the time period of vibration of the strip with mass m1 and T2 be the time period with mass m2. Now, m1 directly proportional to T1 square. Therefore, m1 upon m2 equals T1 square upon T2 square. Thus, two unknown masses can be compared by knowing the values of T1 and T2. If mass of one body is known, mass of the other body can be calculated. Measurement of gravitational mass. The gravitational mass of a body is measured by using physical balance or common balance with which all of us are familiar. Significant figures.